Welcome back to the deep dive, everyone. This is InsideQA, and today we're really getting foundational. We're talking core software testing concepts, building that QA compass. Yeah, our mission today is digging into a really key document, the ISTQB Certified Tester Foundation Level Sample Exam C, version 1.6. But forget just exam prep. We're mining this for the real gold, the practical wisdom, why this stuff matters day to day. Whether you're aiming for certification or just sharpening those QA instincts, we want to know how these principles actually work in the field. So let's kick things off with something that sounds simple but often isn't. What's the real objective of testing? I mean, most folks just say finding bugs, right?
Yeah, that's the standard answer, yeah.
Yeah.
And finding defects is definitely part of it.
Yeah.
But the primary objective, as the source material really emphasizes, it's actually more proactive.
Yeah.
It's explicitly about causing failures and identifying defects. So it's not passive, it's an active process,
Yeah.
intentionally pushing the system to see where it breaks.
Okay, actively causing failures. I like that framing. And that brings up something else I hear causing confusion all the time. Testing versus debugging. Are they basically the same?
Yeah. A really common mix-up, but a super important distinction. Testing, like we just said, that's the investigation. Finding the evidence that defects exist, maybe by causing failures. Debugging, that's a whole separate thing. That's the developer's job usually. Finding the root cause and actually fixing the defect. Tester finds the problem, developer fixes it. Two different roles, two different activities.
Got it. Tester finds the smoke, developer finds the fire, and puts it out. Makes sense. Now, here's a concept that sounds a bit weird at first, but it's critical. The absence of defects fallacy. What is that exactly, and how do we avoid falling into that trap?
The absence of defects fallacy, it's a big one. It basically warns us that, hey, just because your software meets all the requirements and seems bug-free, that doesn't automatically mean it's fit for purpose or that users will be happy.
Okay. Like building a technically perfect product that nobody actually wants or needs.
Exactly. That bridge example you mentioned earlier. Perfect. Technically sound, meets the spec for bridge, but it goes nowhere useful. Fails the user need completely. So to really tackle this, we have to go beyond just verifying requirements. That's verification. We need validation. We need to make sure the system meets the actual user needs and expectations. And a key way to do that, practically speaking, is supporting the end users to perform acceptance testing. It's about building the right thing, not just building the thing right.
Building the right thing. That really lands. Okay, let's zoom out. The big picture. Testing in the software development lifecycle, the SDLC. Is it just tacked on at the end?
Oh, definitely not. That's an old way of thinking. A core principle of good testing today is that for every development activity, there is a corresponding test activity. It's woven in from the start all the way through, not just a final gate.
Okay, woven in throughout. That sounds like the whole shift left idea we hear so much about. What does shifting left actually mean in practice?
Yeah, shift left is more than just jargon. It's a strategic move. It means pushing test activities earlier in the software development lifecycle, SDLC. Why? Well, mainly to reduce the total cost of quality. Finding a bug in requirements, super cheap to fix. Finding that same bug after release can be incredibly expensive. Reputation, rework, everything.
So it's about economics, really. Catching things early saves money down the line.
Absolutely. It might feel like more effort up front, maybe even a bit more cost initially, but the overall savings from finding fewer defects late in the game make it really cost-effective. Plus, it often creates a better quality culture overall.
That makes sense. Prevention is cheaper than cure. Are there development approaches that actually bake testing in from the absolute beginning? Like, test first?
Oh yeah, definitely.
Yeah.
Acceptance Test-Driven Development, ATDD, is a classic example of a test-first approach. With ATDD, you actually write the acceptance test before you write the code. Those tests then guide development. It ensures you're building exactly what the user needs based on those criteria.
Right. Defining the done criteria before you even start coding. Powerful. Okay, let's trace the typical flow: analysis, design, implementation, execution, monitoring, completion. What are some key outputs, the actual testware, that come out of each stage?
Good question. So test analysis, they're looking at things like prioritized test conditions. You might even find defects just by reviewing the requirements or user stories, so early defect reports too. Then test design. That's where you get your prioritized test cases and figure out what test data you'll need.
Okay.
Test implementation is about getting ready to run, building test procedures, those step-by-step instructions, maybe writing automated test scripts, setting up the environment, and finally, test completion. That's wrapping up. You'll produce test completion reports, summarize everything, and document lessons learned for next time. It's a structured process generating useful stuff at each step.
Lots of valuable artifacts generated along the way. Okay, let's talk people, especially in agile teams. Who's doing what? What's the dynamic?
Right, Agile often blurs the lines, which can be good. A lot of the sort of day-to-day test management tasks might actually be handled by the whole team collaboratively. But, for bigger projects or stuff that crosses multiple teams, you might still have a dedicated test manager coordinating things from a slightly higher level, maybe someone outside the immediate dev team. It's less about rigid silos, more collaboration.
That collaboration sounds like the whole team approach. What's the real benefit there? Is it just about everyone feeling involved?
Feeling involved helps, but the primary benefit highlighted is actually improved team dynamics. When quality is everyone's responsibility, developers, BAs, product owners, testers, it just breaks down those us versus them walls. Communication flows better, people collaborate more naturally, you leverage everyone's skills, it creates a synergy,
Yeah.
better team, better product.
Okay, so better teamwork leads to better quality. Makes sense. But on the flip side, what about test independence? Having testers who aren't developers, is that always better? Are there downsides?
The independence question. It's a classic balancing act. The big advantage of independence. Testers are more likely to identify different types of failures and defects compared to developers. They just come at it differently. Different background, different biases, maybe less assumption about how things should work.
A fresh pair of eyes, essentially.
Exactly. But the disadvantage, isolation. Independent testers may become isolated from the development team.
Yeah.
This can lead to, communication issues, lack of collaboration, sometimes even an adversarial relationship. That's not productive.
Right, finding that sweet spot is key then. Okay, let's shift gears to test levels. We hear about component, integration, system, acceptance. How do they fit together? Who does what?
Yeah, they build on each other. Think of it like layers. So component testing, often called unit testing, that's developers testing individual pieces of code, usually in isolation. The focus is verification. Does this little piece work correctly?
Okay, developers checking their own work.
Right. Then you move up. Integration testing checks if components work together. System testing looks at the whole integrated system against requirements. And then acceptance testing. This is really about validation. Does the whole system meet the business needs? Is it ready for users? This is ideally done by end users or maybe product owners. It's about fitness for purpose.
Verification versus validation. Component versus acceptance.
Got it. Now, say you fix a bug. What's next? Just test the fix.
Nope, not quite that simple. First, absolutely, you do confirmation testing or retesting. Make sure the specific fix worked and the original bug is gone. Check one. But then, and this is crucial, you need regression testing.
Making sure the fix didn't break something else.
Exactly. You rerun tests on unchanged parts of the system to catch any unintended side effects. Like that navigation system example, fix a route calculation, then retest other major features to ensure they weren't accidentally impacted. You have to protect against regressions. Confirmation and regression, both vital. Okay, let's clarify static versus dynamic testing. What kinds of problems does each one find best?
Good distinction. Static testing is looking at the work product's requirements, code, design docs without running the code. Think reviews, walkthroughs, static analysis tools. It's great for finding things in the documents or code structure.
Yeah.
Like inconsistencies, ambiguities, maybe security flaws, unreachable code, stuff like that. You're inspecting the blueprints.
Okay, inspecting the plans.
Dynamic testing is the opposite. You execute the software, click the buttons, enter data, see what happens. This is essential for finding issues that only show up when the system is running. Performance problems like slow responses or memory leaks, incorrect calculations, workflow issues, stuff you can only see in action.
Right. Static finds flaws in the plan, dynamic finds flaws in the execution. Now, for the really hands-on stuff. Specific techniques. What's the core difference between black box and experience-based techniques? They sound quite different.
They approach testing from totally different angles, but they work well together. The key difference is the test basis, what you're basing your tests on. Black box techniques rely on the specification, requirements, user stories, design docs. You test the functionality based on what it's supposed to do without looking inside the code. Inputs and expected outputs.
Like testing a TV remote without knowing how the circuits work?
Exactly. Experience-based techniques, though, they leverage the tester's knowledge, intuition, and experience. Maybe experience with similar apps, common failure types, or just a gut feeling about where bugs might hide. Sometimes you don't even need a detailed spec for this.
So spec-driven versus intuition-driven. Interesting. Let's take a couple of common black box ones. Equivalence partitioning and boundary value analysis. How do we use those? Give us a sticky example.
Okay, these are workhorses for test design. Let's use that pin validator example. Needs a 4-digit pin in, not all digits the same. With equivalence partitioning, EP, you divide inputs into groups that should be treated the same way by the system. So valid length, 4 digits, invalid length, less than 4, more than 4. With invalid length, all digits different, good, all digits same, bad, some digits same, maybe good, depends on rules.
Grouping similar inputs.
Right. Then boundary value analysis, BVA, focuses on the edges of these partitions. That's where errors often happen. So for the pin-in, boundaries are around length 4, test 3 digits, 4 digits, 5 digits. For the all digits same rule, test 1111, invalid boundary, and 1234, valid. Or another BVA example, rule is value 100 OR, value 200. The critical boundaries to test are 100, 101, 199, and 200. Testing right on and just off the boundary.
Testing the edges, that makes perfect sense. Boundaries are tricky. Now, decision tables. They help with complex logic. How can they specifically help find contradictory rules?
Decision tables are brilliant for untangling complex business rules. You map all possible combinations of conditions, inputs, to the resulting actions, outputs. Let's say you have rules for driving test results first attempt. Theory passed, practical passed. The table lists all yes-no combos. If one specific combination of inputs like not first attempt, theory failed, practical failed, actually matches 2 different rules in your table and those rules lead to different actions, boom, that's a contradiction between rules. The logic itself is flawed. The table makes it visible.
So it exposes logic flaws before they become code flaws. Very cool.
What about state transition diagrams? If we have one, how do we figure out the minimum tests to cover all the transitions? State transition diagrams are great for visualizing systems that move between different states, like an order status or user login process. To get 100% transition coverage, you need to trace paths through the diagram, ensuring every single arrow transition is followed at least once. You look for the minimum number of start-to-end journeys that achieve this. In that room, request example, requesting confirmed, waiting list end. Maybe one path covers most transitions, but you need another path just to hit waiting list confirmed, and maybe a third just to hit waiting list end. The example said at least 3 test cases were needed to hit every valid transition. It's like planning efficient routes on a map.
Finding the minimum set of journeys. Got it. Okay, a quick touch on white box. What's branch testing? And how do white box techniques actually help black box testing?
Branch testing is about code coverage. You want to ensure your tests execute every possible branch, every decision outcome in your code, like every if statement's true and false path. In a control flow graph, it's about covering all the edges or arrows.
Testing all the decision points in the code.
Exactly. And how it helps black box. The best way is using white box coverage measurement. You run your black box tests based on specs, then use a tool to see how much of the code, or actually how many branches, those tests actually executed. It gives you objective feedback. Your black box tests covered 80% of the branches. Maybe you need more tests to hit the remaining 20%. It adds confidence and helps target gaps. It's like an X-ray for your test suite.
Using code coverage to measure black box test effectiveness. Smart. Back to experience-based. What's a fault attack? Sounds aggressive.
It kind of is, in a good way. A fault attack uses a predefined list of possible errors, defects, and failures. Common mistakes programmers make. Typical system weaknesses like buffer overflows, division by zero, bad input handling. And you intentionally design tests to trigger those specific faults. You're proactively attacking known weak points based on experience, not just randomly exploring.
Like using a known most wanted list of bugs to guide your testing. I like it. And this one surprised me. Checklist-based testing can increase coverage. How does that work? I think checklists might limit things.
Yeah, it seems counterintuitive, right? But if the checklists are relatively high level, it allows for some variability in the actual testing. So 2 testers using the same high-level checklist item like check user login functionality might try different usernames, different passwords, different browsers, different network conditions. That variability means together they actually explore more than if they followed identical super detailed steps. It encourages a bit of exploration within a structure.
So high-level guidance plus individual tester ingenuity equals broader coverage. Interesting. Last one on techniques. Back to ATDD and acceptance criteria. What's the difference between scenario-oriented and rule-oriented criteria?
Good question. Helps clarify what you're testing. A scenario-oriented acceptance criterion describes a specific user journey or example, like when a customer adds an item, goes to checkout, they must log in. It's a concrete story. A rule-oriented acceptance criterion focuses on constraints or regulations the system must follow, like password complexity must meet policy XYZ or system must comply with GDPR data deletion requests. It's about adherence to rules, not a specific flow.
Scenario is a story, rule is a constraint. Got it. And testing that user story about special users having regular user rights, a good test would be.
A practical test would be to check that a special user can access floors 1, 2, and 3, assuming those are the floors regular users can access. You're verifying they inherit the correct baseline permissions.
Makes sense. Okay, moving beyond techniques to managing the whole process. Test plans, what must be in one, and maybe more importantly, what shouldn't be.
A solid test plan is your roadmap. It absolutely needs things like entry criteria and exit criteria. When do we start testing this level? When are we considered done, e.g. 100% branch coverage achieved? It should also include things like documentation templates for consistency and explain how the test strategy fits with the overall project or organization strategy.
Right.
But critically, it should not define detailed test data and expected results for component tests. It's way too granular for the plan. That detail belongs in the actual test case specifications or scripts. Keep the plan strategic.
Plan is strategy, not low-level tactics.
Okay? How about estimating effort? Especially for future sprints or iterations, feels like crystal ball stuff sometimes. It can feel that way, but you can use past data. The source mentions an extrapolation model. One example formula with EN confers 3 and 1 plus A and 2, 4. E is the estimate for the next iteration, N, and A is the actual effort from the previous two, N1 and N2. So if iteration 3 took 8 days and iteration 4 took 7, you plug those in to estimate iteration 5. The example calculation came out to 6.5 person days for iteration 5. It's not perfect, but it's a data-driven way to get a reasonable estimate, much better than just guessing.
Using past actuals to predict the future, sensible. Okay. Prioritizing and scheduling tests, especially with dependencies, that sounds like a headache. How do you untangle that?
It definitely requires careful planning. You have to balance the business priority of a test case against any technical dependencies it has. Maybe test case 7 is top priority, but it needs test case 4 to run first. Maybe TC4 sets updated TC7 needs. Well, PC4 has to run first, even if it's lower priority itself. You map it all out, priorities, dependencies, and then figure out the most efficient execution sequence. The example showed that, following the rules, the 6th test case executed might be test case 3. It's a sequencing puzzle.
A logical puzzle indeed. Okay, testing models. The test pyramid, what does that show us, and how are testing quadrants different?
The test pyramid is a great visual metaphor. It primarily shows that tests may have different levels of granularity and suggests a healthy distribution. Lots of fast, cheap unit tests at the base, fewer integration tests in the middle, and even fewer slow, expensive UI or end-to-end tests at the top. Focus automation lower down.
Right, lots of small tests, fewer big ones.
Exactly. Testing quadrants, developed by Brian Merrick, are different. They group test levels and test types by several criteria on a 2x2 grid. The axes are often things like business-facing versus technology-facing and support the team versus critique the product. It helps teams think strategically about what kinds of testing they need across the board in an agile context. Different perspectives.
Two useful models for thinking about test strategy. How does product risk analysis actively shape our testing? Does it change what we do?
Absolutely, it changes what we do. It's not just paperwork. The assessed risk level helps us to select the rigor of testing. If a feature is high risk, big negative impact if it fails, data loss, security breach, huge financial hit, you test much more thoroughly. More test cases, more techniques, maybe more experienced testers. Low-risk features get lighter testing. It guides resource allocation directly.
Focus effort where the danger is highest. Makes sense. Which part of the whole test process relies most heavily on test progress reports?
While they're useful throughout, test completion definitely makes the most use of test progress reports. Those ongoing reports feed directly into creating the final test completion report when you're wrapping up a phase or the whole project. They contain the evidence and summary data needed for that final sign-off.
The final summary relies on all the reports that came before. Okay. Configuration management. How does that help testing? And what's not its job?
Configuration management CM is like the librarian for your project artifacts. It ensures things have unique IDs, versions are controlled, especially code commits, changes to test environments are tracked. It also helps ensure requirements are clearly linked in test plans so you know what version you're testing against. Traceability. What's not its job? Tracking defect status. Ensuring all identified defects have an assigned status. That's defect management, a separate but related process. CM manages the items. Defect management manages the bugs.
Good distinction. Speaking of bugs, what's one crucial piece of info often missing from defect reports that really frustrates developers?
Oh, this is a classic pain point. For something like a login button not working defect on a website, the information developers desperately need, and often don't get, is the specific test environment elements and their version numbers. What browser, which version, what OS, what device, any specific plugins running. So often, a bug only happens in one specific setup. Without that info, the dev response is often, cannot reproduce, it wastes so much time.
The environment details, such a golden nugget for better bug reports. Okay, nearly there. Tools. What kind of tools really tie this whole process together?
Test management tools are often the central hub. They're incredibly valuable because they help increase the test process efficiency. How? By facilitating the management of the software development lifecycle, SDLC. Requirements, tests, defects, and configuration management all in one place. Requirements linked to tests, tests linked to results, results linked to defects, traceability, and efficiency.
The central command center. And finally, test automation. What's its single biggest, most impactful benefit? Is it just about speed?
Speed is definitely a benefit. Running tests faster is great. But the most impactful benefit, it's the prevention of human errors through greater consistency and repeatability. Automated tests don't get tired, they don't have a bad day, they don't accidentally skip step 7, they run exactly the same way every time. That consistency and reliability, especially for regression testing, is huge. It frees up humans for more complex, exploratory testing.
Consistency and repeatability. More reliable than humans for repetitive tasks. What a journey. That was a really comprehensive deep dive. We went from the core why of testing through the SDLC, teams, levels, techniques, managing it all, and finally tools and automation.
It really covers the foundations, doesn't it? And the insights from that ISTQB material, they aren't just abstract concepts. They're genuinely the bedrock principles for building quality software effectively. It's about understanding the why, not just the what's.
Absolutely. So for everyone listening, the question becomes, what does this mean for you? How can you take even one insight, maybe thinking more about validation or applying boundary analysis or improving your defect reports and apply it to your work tomorrow? Where do you want to dig deeper on your own quality journey? A huge thank you for joining us on the deep dive today. We hope this exploration sparked some ideas and gave you valuable takeaways. Until next time.